This is the epic story of Earth's largest freshwater lake by surface area. A body of water so massive, it contains 10% of the world's fresh surface water and creates its own weather systems. Lake Superior isn't just big, it's a geological marvel that defies comprehension, holding enough water to flood all of North and South America to a depth of 30 centimeters. Let me put this into perspective for you. We're talking about 82,103 square kilometers of surface area. That's larger than the entire country of Austria. The lake stretches 563 kilometers from east to west. That's like driving from Boston to Washington, D.C., and contains 12,000 cubic kilometers of water. But these numbers barely scratch the surface of what makes Lake Superior truly epic. The story begins 1.1 billion years ago with the mid-continent rift, one of the most violent geological events in Earth's history. Picture the North American continent literally trying to tear itself in half. Massive volcanic eruptions and tectonic forces created a rift valley that would have rivaled today's East African rift. For millions of years, lava flows filled this enormous gash in the Earth's crust, creating rock formations that still define the lake's rugged shoreline today. But the lake we see now? That's a much more recent creation. Just 10,000 years ago, a blink of an eye in geological time, the massive Laurentide ice sheet began its final retreat. As it melted, it left behind glacial Lake Duluth, the ancestor of modern Lake Superior. The weight of the ice had actually depressed the Earth's crust, and as the ice disappeared, the land began to rebound, a process that continues today. Here's something that might blow your mind. Lake Superior is so deep that its bottom actually sits below sea level. The maximum depth reaches 406 meters. That's 1,333 feet. If you place the Empire State Building at the deepest point, only its antenna would break the surface. The average depth of 147 meters means this lake holds 3 quadrillion gallons of water. That's 3, followed by 15 zeros. The Ojibwe people who've lived along these shores for centuries call it Gichigami, the Great Sea. And they're not wrong. Lake Superior behaves more like an ocean than a lake. It has tides, small ones at about 5 centimeters, but tides nonetheless. It generates massive storms with waves that can reach over 9 meters high. The lake creates its own weather patterns, including the infamous lake effect snow that can dump meters of snow on downwind communities in a matter of hours. Speaking of weather, let's talk about temperature. Lake Superior is cold, really cold. Surface temperatures range from freezing to about 13 degrees Celsius in the warmest spots during peak summer. The lake rarely freezes completely. The last time was 1979. This isn't because it's warm. It's because the lake is so massive and deep that it takes an extraordinarily cold winter to freeze all that water. The cold water has a remarkable side effect. Shipwrecks are preserved almost perfectly. Over 350 ships rest on the bottom, including the famous Edmund Fitzgerald that sank on November 10, 1975. Gordon Lightfoot immortalized that tragedy with the haunting line, "The lake, it is said, never gives up her dead." He wasn't being poetic, he was being accurate. The water is so cold that bodies don't decompose normally and don't fill with gases that would make them float. They stay on the bottom, preserved in the icy depths. The water retention time, how long a drop of water stays in the lake, is 191 years. Think about that. Water entering Lake Superior today won't leave until the year 2215. This incredibly slow turnover makes the lake extremely vulnerable to pollution, but also keeps it remarkably clear. Visibility can extend to 27 feet deep, making Superior the clearest of the Great Lakes. Scientific speak for having very few nutrients and very clear water. Now, you might wonder why I keep emphasizing the cold. Well, it shapes everything about this lake. The cold water holds more oxygen, supporting a unique ecosystem. Lake Superior has its own species of trout found nowhere else. The cold also affects human activity. When French explorers first arrived in the 1600s, they named it Le Lac Supérieur, the upper lake, because it sat above the other Great Lakes. Etienne Brulé became the first European to see it in 1622. but the Ojibwe and other indigenous peoples had been navigating these waters for thousands of years. The geography of Lake Superior includes some mind-bending features. Take Isle Royale, for example. It's an island in Lake Superior that contains its own lake, Siskiwit Lake. That makes it a lake on an island in a lake. But wait, it gets better. Siskiwit Lake has its own island, Ryan Island, and Ryan Island has seasonal ponds. So you have ponds on an island, in a lake on an island in a lake. Try wrapping your head around that geography. The shoreline stretches for 4,387 kilometers, longer than the entire western coast of the continental United States. This coastline includes everything from towering cliffs to sandy beaches, from industrial ports to pristine wilderness. Major ports like Duluth, Minnesota, the largest, and Thunder Bay, Ontario, serve as crucial transportation hubs. These ports exist because of another geographic marvel, the Soo Locks, which opened in 1855, connecting Lake Superior to the lower Great Lakes and ultimately to the ocean. But here's where the geography gets really interesting in our modern context. Lake Superior is experiencing rapid changes. Average water temperature is increasing by 2 degrees Fahrenheit per decade, faster than almost any other large lake on Earth. Water levels hit near-record highs in 2019 and 2020, and they remain above average in 2024. These changes affect everything from shipping to shoreline erosion to the survival of cold-water fish species. The lake faces modern challenges that its epic geography both helps and hinders in addressing. Invasive species like zebra mussels, first detected in 1989, and sea lamprey have altered the ecosystem. Proposed sulfide mining near watershed areas has sparked fierce debates between environmental groups and economic development advocates. The Great Lakes Compact restricts water diversion, but as drought affects other regions, pressure mounts to tap into this massive freshwater resource. Climate scientists studying the lake have discovered it's a kind of canary in the coal mine for global environmental changes. In 2014, the lake experienced record ice coverage at 95%, yet overall, ice cover is declining. The lake's size means it influences regional climate, but global climate change is now influencing the lake in return. New technology is revealing secrets hidden in Superior's depths. Advanced sonar systems are discovering previously unknown shipwrecks. Satellite monitoring provides real-time data on water temperature, ice coverage, and algae blooms. Researchers have even detected microplastics in the lake's water, a sobering reminder that even this massive, remote body of water isn't immune to human impact. Tourism to Lake Superior's shores has rebounded to pre-pandemic levels as people seek to experience this geographic wonder firsthand. They come to see the pictured rocks, the Apostle Islands, the rugged North Shore. They come to feel the power of November gales and the serenity of August sunsets. They come because there's something primordial about standing on the shore of a lake so large you can't see the other side. As I researched this lake, one quote from author Mary Doria Russell stuck with me. Superior is cold year-round. Icy, frigid, bathwater is never a term that describes Superior. It's a reminder that this lake doesn't exist for our comfort. It exists on its own terms, shaped by forces far greater and older than human civilization. Lake Superior represents something increasingly rare in our modern world. A geographic feature so massive, so powerful, that it still humbles us. In an age where we've mapped every corner of the Earth, where we've put footprints on the Moon, Lake Superior reminds us that nature still operates on a scale that defies human comprehension. This lake that holds 10% of the world's fresh surface water, that creates its own weather, that preserves ships and sailors in its icy depths, that supports unique species and ancient ecosystems. This isn't just a lake. It's a geographic phenomenon that connects us to deep time, to the massive forces that shaped our planet, and to the delicate balance required to preserve such wonders for future generations. The epic geography of Lake Superior isn't just about size or depth or volume. It's about a place where geology, climate, ecology, and human history intersect on a scale that challenges our understanding of what a lake can be. It's about water so vast it behaves like a sea, so cold it stops time, so powerful it shapes the land around it. That's the true epic nature of Lake Superior. Not just that it's big, but that it's a world unto itself, following its own rules, keeping its own time, and reminding us that some things on this earth remain larger than life.